Alright guys, so we're going to talk about subatomic particles. Okay, so what do you think subatomic means?
Well, I know what atomic means. That means atom, right? It has to do with the atom. So subatomic would be like smaller than the atom?
Yeah, that's exactly
right.
Or
inside the atom?
Yeah, it's the different pieces of the atom, so the parts of the atom.
Oh, okay.
It's what makes up the atom itself.
Got it.
So let's talk about a couple of the different particles that we have.
Okay. We
have the protons and the neutrons that make up the majority of the mass.
Okay. Really? Okay, protons and neutrons. I'm going to write those down. So we got, so you said they're particles, and that they're subatomic. So I'll put up here that subatomic means parts of the atom.
It's just like we have a car, so we have the wheels, and we have the frame and the engine. So this is just what makes up the atom.
It's everything that builds the atom, basically. Right. Okay. So then, and you said that under particles, so we have the protons, and we have neutrons.
Brianna Tristan.
Is that it?
We're here on campus.
Well, we also have
Please meet your right at the bus stop area.
Electrons around.
Brianna Tristan.
We have electrons
Electrons.
too. And they make up a cloud. So they don't contribute to the mass then if they're just kind of like on the outside?
Well, while technically they have mass, it's so negligible that we don't really count it for the mass of the atom.
Oh, okay. I heard that like the atoms have positive and negative parts.
Oh yeah.
Is that what these do?
Oh, absolutely. So, well, we have a charge for a couple of these different pieces. So protons are positively charged.
Protons are positively charged. So that's easy to remember. Protons are positively charged. Okay.
So we'll start with C.
So that's information I definitely want to know. Charges, the protons are positive.
The electrons kind of are the opposite in charge of the protons, so they're going to be our negatively charged particles.
Okay, protons are positive, electrons are negative. So if I have both of those together, wouldn't that mean the whole atom would be neutral?
Well, yes, it would be. And whenever we have a neutral atom, it's going to be the same number of protons as we have electrons. So they should always be the same amount, unless we have ions, but we'll talk about that later.
Okay, so most of the time, or like in general, the atom's going to be like very balanced out.
We should expect it to be neutral.
Okay, I got you. What about the neutrons? What charge do they have?
Well, neutrons, just like their name, are going to be neutral.
So 0, they're neutrally charged, so they don't contribute to any charge. Okay.
No charge at all, no.
And you did say that protons and neutrons are what contribute to the mass. So how much mass do they have? If I have one atom, how much mass do the protons and neutrons contribute?
So they're so very, very, very tiny that we have a specific unit just for them called an atomic mass unit.
Ooh, okay.
So one proton or one neutron will have one AMU mass unit.
All right, so AMU, the proton contributes 1. It has 1 mass unit, atomic mass unit. Okay.
And the neutron is just like the proton, just without a charge, so it also has 1 AMU.
Okay, so those two together make up the mass. And you said electrons are so tiny that they really don't have any mass
No
at
mass.
all. Okay. So that's 0. Okay. And is there like, I don't really like writing out the whole proton, neutron. There's just a lot of writing. Is there any symbol, like anything like I can shorten it with?
Yes, so we use symbols. We can use symbols with them. So the proton's going to be a P and a plus symbol.
Because they're positive, right?
Positively charged protons. Neutron's going to be an N with kind of a little clear circle on the upper right to kind of show a 0.
Okay, because they're neutral. Right.
And then the electron's going to have an E with a negative dash.
Well, that's easy to remember.
So it's just pretty much the first letter in their charge.
Well, cool. Okay, so protons have a P, neutrons have an N, and electrons have an E. Okay, that's easy to remember. And you said the atomic mass unit is how we measure the mass of the atom, or the parts of the atom.
The parts of the atom, right.
Okay.
So if we add up all the protons and the neutrons, we can get kind of an overall mass of that atom.
Oh, okay. So protons and the neutrons.
So if we add up all of our protons, we add up all of our neutrons, then we can kind of say this atom has a mass of this many AMU.
Wow. Cool. Okay. Now, what do atoms look like? We did talk about different models of the atom, and that, I mean, like the one that I've seen is like the hula hoop rings. I see that one most of the time. Is that really what atoms look like?
So that's a really good representation to kind of learn of what an atom looks like, but it's not really what an atom would look like. But if we want to look at just the basic structures, we can start with the nucleus.
Okay.
And the nucleus is going to be that little ball in the center. And it's made of protons and neutrons.
So protons and neutrons go in the middle. So I'll use different colors because it's just easy to keep track of them that way. If this right here is a neutron, how many can I make? Maybe like 3?
Yeah, let's do 3. 3 and 3.
So we got some neutrons right here. And I'll make some protons that are orange. I like orange, it's my favorite color. But I guess since, you know, they're not really, probably not those colors, I should probably put the charges in the middle.
Yeah, so the protons would be positive and the neutrons would just be kind of empty.
Okay,
no
cool.
charge.
So they're located in the nucleus. So I'll put that that's what that is. It's a nucleus.
Yeah, and the nucleus is just where all the protons and neutrons kind of hang out in this really dense ball in the center.
And that's where the mass of the atom comes from. Oh, atom.
And then surrounding this nucleus, that's where we have our electron cloud.
Electron. Is it really like a cloud? Like kind of, you know, bumpy looking?
Well, I mean, it takes different shapes, but just for simplicity, let's just draw them as rings.
Okay, those rings, like hula hoops.
Yeah, like hula hoops.
Okay.
And this is mainly just to show the different energy levels that these electrons can take. So
the lower energy levels, I do remember that from the reading, that the lower energy levels are going to be closest to the nucleus. And then we can put some more out here. Oh, but I want this one to be neutral, so it's got to have the same number of electrons as it has protons. So I got 3 protons and 3 electrons.
So that's a nice neutral atom.
Cool. And you said this is the electron cloud. Okay, and I'll label my protons and neutrons.
So now we want to look at the identity of this. And if we really wanted to say what element is this, we would count our protons.
Oh.
The proton's what gives it an identity.
Okay.
So in this case, we have 3 protons, so we would have lithium.
Lithium, so that's actually the atomic number then. Like if I looked at the periodic table, it would be this number up here? Cool, okay. So it's got 3 protons, so that means it's got an atomic number of 3, and that tells me which element it is on the periodic table. And then what about its mass? You said that protons and neutrons contribute to the mass. So I have 3 protons and 3 electrons, so that means that my mass would be 6. Okay.
Yeah, 3 protons, 3 neutrons, so the overall mass would be 6 AMU.
Wow. So that's what that little square on the periodic table means.
Yep. Well, I would say, though, normally on the periodic table, this bottom number is going to be an average mass.
An average mass. Okay, because it can change, right?
Right, and that's when we get into isotopes.
Okay, which is later.
Which is later on.
All right, cool.